we have local class. Ah. Hmm.
In classes,
Hmm.
like closer in Java.
All inner class implementations or closure concept. Okay, so when we go for a local inner class or anonymous inner class, in that scenario, the variable something comes from outside should be final or effectively final. That is the concept. Okay. Any other questions?
So in the lambda, we define the object type and then the variable. But I still don't understand why we remove the object type.
So we will talk about lambdas today much. So when we talk functional interface, I'll tell you everything today. Okay, we will have deep knowledge on lambdas today only. So yesterday just we have understand the concept of closure with inner class. So today we are completely focusing on functional interface and that implementation. Then you will get a clear idea about lambda implementation. Any other questions you have from the homework or something? Okay, let's quickly do the recapture what we discussed yesterday. So yesterday we discussed about the conflict issues with the Java 8 interface, right? So pre-Java 8, every methods are unimplemented. We have no conflict. But from Java 8 onwards, if a two interface has same method signature, either both are implemented or one implemented and one unimplemented, definitely that class must override the method. If it is an interface, it can make it simply an abstract method or provide the default implementation. If my parent class have the same signature and the interface also have the same signature, at the time, if a class implements interface as well as inherit from the parent class, at the time we have no clash, super class automatically wins. And also we discussed about the futures of a functional style of programming, right? Do you remember what are the futures or advantages? Declarative. So programs are declarative. Instead of how to do, we just simply say what to do, and which has a referential transparency, which means nothing comes from outside cannot affect the status of your object. And thread safe, we can do parallel programming with those lambdas, right? The code becomes more readable, then easier to understand and maintainable. So this was we are discussed yesterday. And what is functional interface? An interface has only one unimplemented method is called functional interface. The implementation of functional interface technically called as functor. The body of your implementation is called as closure, right? So pre-Java 8, the closure concept can achieve with the help of inner classes. So either a member inner class or a local class or an anonymous class. When we use local inner class or anonymous class, something comes from outside should be final or effectively final. Okay, that's what we discussed yesterday. So today we will be focusing on how to use the API functional interface as well as how to create our own interfaces, functional interfaces. So that's about the lambda signature we discussed. Left side, you have parameters. This is your lambda operator and the body of the coding. So let's talk about free variable. I'll come to that part free variable later. Okay. Let's go with how to create your own functional interface. And let's talk about how to create your own functional interface. So as we all aware of it, what do you mean by functional interface? An interface has only one unimplemented method. Okay, let me put my interface. This is your interface. Okay, so if this interface can have only one unimplemented method, for example, it has an add method which takes two arguments. The return type is int add int x comma int y, right? Is this functional interface? Yes. So I'm going to add another method. Is this functional interface? No. So for example, if I want to do the compiler verification, what you can do it is on the top, you can put the annotation at functional interface. So this is not mandatory, but you will get compiler verification. If you are sure your interface is functional interface, you don't need to do that. But when you add something in the future, then it won't be a functional interface. So to get that compiler verification, you can put this annotation. It will tell you that it is invalid functional interface. So for that purpose, you can add an annotation with this. Okay, let me remove this one and I'll do something else here. Default. So you should understand this signature of functional interface rules. You will have some questions like this. Okay, so I have a int sub int x int y. Then I'm going to return x minus y. Is this still functional interface?
Yes.
Yes. So a class can have multiple implemented methods. So many default, many static methods, but one unimplemented. Still, it is a functional interface. So I'm going to do this. Even no need of public. Let's do string to string. Is this functional interface?
No.
So this toString method by default comes from object class. So you can include object method. So as we all aware of it, all methods in your interface are public, whether you give the keyword or not. So this method comes from object. So all object method you can include without unimplemented, but still it's a functional interface. So these are all the rules. So you have to be aware of these rules. So hash code will return an integer, right? Still it is an, you can test it by giving this keyword, right? You will get compiler verification, whether this signature is correct or not. This also comes from object. So you can include all those object methods. It's not included for the functional interface. So what else we have? Equals, right? So Boolean equals will take object. Still it's a functional interface. So these are the rules. I can put it here. Only one unimplemented method. So, and you can have multiple implemented, default and static and implemented. Let me put a multiple command lines, put the rules. So here are the rules for functional interface. Only one unimplemented method can have many default and static implementer methods. Also can have all object methods, Okay, so this is a functional interface. If you follow these rules, it is a functional interface. Any question on these rules? Okay. So now here is my interface, which has only one unimplemented method. So all functional interfaces can implement in Lambda. Okay, so here is the next point. We are going to learn about all functional interfaces can implement with Lambdas. So all for only functional interfaces. Okay, not any other interface. So all functional interface can implement with Lambdas. Okay. Now, I want to do the implementation of this functional interface. So I hope we remember the rule, right? So what is the name of your interface? My interface. So when you want to do the implementation, every Lambda expressions can implement by functional interface. So what is the type of your Lambda expression? Functional interface. So what is your functional interface? That is the type for Lambda expression. Every Lambda expression has a type. The type is any of your functional interface. Okay, so what is my name of the interfaces? My interface, give a name for your interface, maybe some interface. I'm going to do sum of two values. Okay, so the left side, your declaration, how you declare an object or primitive type or whatever it is, your object. Now, on that side, what we need to do it here is we have to implement that. This is your object name, right? How the Lambda implementation? The signature is signature. Okay. Parameters, body of the implementation. Okay, look at this interface as only one unimplemented method, right? What the method name is? Add. How many arguments I have here? 2 arguments. So on the left side, what I need to do? Your arguments, right? Then your lambda operator. Then what is the implementation I want to do? Simply, I want to sum of 2 values, right? So x plus y, even no need for return. So when we do like this, it will automatically infer, because with this interface, I can only implement the method which is unimplemented. So we no need to specify the method signature and what is the argument type, what is the return type. It automatically infer from the method interface, whatever you have given. So for that reason, even I no need to specify int x comma int y. So it will automatically infer the type. This is called type targeting. Okay, so this is not needed. So that's way we can have this one. And how can I invoke this object? So your object name is sum, right? So it will return an integer value. So I can put integer result is equal to your object name is sum dot which method we need to execute. I want to execute the add method. Then you can pass this values. So this way we can implement the lambda. Now you might wonder, for adding these 2 numbers, why should I have these functionalities, right? But this is not the real purpose. We will learn tomorrow stream pipelines. So all stream operation must accept a functional interface. We have several functional interfaces and the methods. So at that time you realize the importance of functional interface. Tomorrow, for getting the better understanding, we'll go with simple example, but this is not the real purpose of functional interface. Even I can do simply 2 numbers, right? Why should I have interface and add behavior? For understanding, we are doing this one, but this is not the purpose. So you will realize it tomorrow. Okay, yeah.
So I how to target to that type?
Okay, because you're declare this object as a type of interface, right? When you implement this lambda expression, we have only one unimplemented. Your compiler will automatically infer the type. For example, if I do 12.5, what will happen? This is compiler verification. Your compiler will automatically infer your argument type as well as return type. Now what happened? It say, see here, the argument is not applicable for double comma integer. So your compiler will automatically verify that one.
So we only use x and y, but we don't need to push the type integer there.
Yeah.
So my question is how it auto target to the type integer. Like
that's what I said. You declare your object as interface, right? This lambda expression has type. What is the type? Interface. So I don't think so. Do you know that? This is the name.
yeah.
Okay. If I give that name, automatically it will infer the type from the interface. It's like a compile time polymorphism, how it works, right? When you have overloaded methods, if you change the signature, compiler will tell you. The same way, automatically, when you make a type, it will infer all the input argument type as well as the return type from the interface. Because of functional interface, we have only one unimplementer. So automatically compiler will verify this method signature. We cannot implement any other method.
So that inside you the detection to check the interface, then they find
Yes.
the method.
Yes. Yes. That's called target type. Okay. So I want to print this result. So as usual, you can print the result. So it will print the result 12 and 13, 25. Okay. So this way you can create your own interface and you can do the implementation. Okay. So that's what over here, there is a try function interface. I'll come to for this by function. Okay. So this is the way you can create your own interface. So over here, the interface name is called try function. So in that main method, which will take 3 arguments, actually, this is a generic type. I'll show you that also in this moment now. Okay, let's go with that. Generics will be covered in chapter 10, but if you want, you can create a generic interface. Okay, let's create. So this is for only the interface signature. We can go with generic. Okay, so before that, let me show you the user defined that signature. Then if I come for this one, it makes more sense. Okay, so when you go to this API library, that link was, so here. Okay, so you can copy this link from the slide number 40. You can able to know how many default functional interfaces are available in Java. You can refer from this link. So I will use those functionalities first, how to use your APIs. Okay, so when you copy and paste this link, you can able to see so many functional interfaces. Okay, so we can go for this interface. If that is not suitable, you can create your own functional interface. Okay, let's say this one by function. Let's look at this one. So it takes 2 arguments, T and U, 2 different types of argument, and return a value. So that is the meaning. If you want to understand the interface signature, go over here. The by function is a functional interface. Okay, what is the unimplemented method here is apply, which takes 2 arguments, T and U, and it is going to return the value of R. So let's go and check it inside IDE. Okay, you can look at that interface. The name is called by function, which is from java.util.function. Take a look at this one. Okay, so all interfaces are generic, so you can pass any data type. So I can pass 2 different data types. The type 1 is T and the type 2 is U. You can pass int, float, or both int, comma, integer, whatever you want. And the R indicates return type, which has one unimplemented method, which is apply, takes 2 argument and return the value. So now how can I use this by function inside my code? Let's use this one. So the purpose of by function is take 2 inputs and return 1 value. Accordingly, you can use that purpose. So what is the function? By function, right? So you should have some import library when you use it. So already I have that one. Otherwise, you need to import it. Okay, let me remove this one. Okay, so what it will say? Automatically, you have to import. So before that, we should complete the signature. Okay, so here it's similar like how you create an array list. We need to specify the parameterized type for the array list. The same way, your by function can what kind of type it is going to take. You need to specify both input types as well as return types. So type T, according to this signature, what I need to specify? T, U, and R. When you declare as a type of by function, you have to specify these 3 types. So come over here, and I always within the angle bracket, you can pass only object type. You cannot pass primitive types. So which means int means what I need to do? Integer. So the first input type is integer. Even the second type also you can go with integer. I'm going to do with double, and the return type I specify as double. Then put your name for this by function. So by 1 is equal to the implementation. So you have to take 2 inputs. Don't pass 3 inputs. What's your method signature? We'll take 2 value and return 1 value. So 2 values are put any number. I mean argument name, A comma B or X comma Y, that doesn't matter. Okay, 2 name for the arguments. So what I need to return here is, I'm going to do this, A plus B. So now you need to import this package. So import java.util.by function. So this is the way you can make use of your API library. If there are so many API libraries are available, which doesn't work for your implementation, you can create your own interface, whatever you want. So now how can I call this method? Which return an integer. I have already the result variable. I'm going to reuse the same variable because it is a double, right? So the return type is double. D is equal to my object name is bi1 dot function name. Apply, then pass two values. Then you can print the result. Okay. So let's run this code. It gives you the same answer. Okay. So like that, you can use your interface. Let's look at some of the interface to show you from here. Okay. Let's say by consumer, what it will do. Look at the signature of by consumer interface. It takes two arguments, but it does not return any value. So in that scenario, you can use by consumer. Take two different arguments, whatever you want, you can do it, but no return value. Then you can choose by consumer function. So you can refer for each function purpose. You can read it from here. Okay, let's go and see some exercise. For your practice, please open your IDE. At least one or two, if you work it out, then you will get better understanding. Okay. Here, you have to create your own functional interface, which is my interface. And this interface should return any random number. Okay, you have to return some number, but no arguments. Your interface, create your interface. Okay, here is the requirement. Define your own functional interface that could be used as a wrapper for a function that takes 0 argument and return an integer. So what we can do? You have to return any random integer, right? Just use the random class and return some number, but no arguments. Can you create one user defined interface? Create by your own. Then use it to define an object that produces random numbers in the main method. Test your code with the Lambda implementation. Okay. If you want, you can write it in a paper. Better, you can type it on IDE. Then only you can understand the signature, or if any error comes, you can able to know that. Please 10 minutes, 5 to 10 minutes time. Open your IDE and do this exercise. So inside the interface, the method name, you can use it as produce. The unimplemented method name can have the name produce. So here is your test class. You're creating an object and you can call that method. Okay. So this is the regular implementation. You don't do that. You can do Lambda implementation. That's fine. Are you guys done? Okay, 10:30, I'll get back to you. Okay, 3 more minutes. Okay, can you listen here? What is the answer for the first question? Is this a functional interface? The code 1. Why? ToString is comes from the object class, but there is no unimplemented method. So this is not a functional interface. Or how about this one? Yes, it is a functional interface. ToString comes from object. We have one unimplemented method X. It should be functional interface. Okay, so let's go and check the solutions for the problem 3, exercise 8.2, that also in your in-class exercise. I hope I have to enable that one. I forget to do that. Okay. Which one? Because this method comes from object class. There is no unimplemented method. How come it become a functional interface? Functional interface means one unimplemented method you need. Huh? That's what I said. This comes from object class. That is not calculator, right? So ToString comes from object. Okay. Okay, let me show you. Okay, instead of discussion. Okay. So go over your interface. Okay. So create, let's go over here, exercise 8.2, 8.1. Oh, that's what the number, 8.2. Exercise 8.2. Here is your interface. Let me put a command line here. It will throw some errors. Okay. If I put string to string, is it functional interface? This is not a functional interface. When I put this annotation right now, no issue, right? Compiler will not show you anything. Okay, I will ask this question in the quiz. Many people lose points, right? Make sense or not? There is no method to implement using this functional interface means you should have one unimplemented method. All object methods are not calculator. Okay or not? Abdullah, I need yes or no?
It might be saying.
Don't compare with .NET C#, okay? Java rule, this is Java rule.
No, I know that it's also similar to the delegate or functional in C function.
Okay, this is the rule, okay?
But I didn't get it.
You did not get it, what should I do?
You know that, but it will not count it for. So to see is keep it to be.
Object methods are not implemented using lambdas, okay? Only your interface unimplemented method you can implement with lambdas, okay? So that's the rule. Okay, let's go and see the method here is, this is our pre-Java 8 implementation. If I have interface, I should have some class which implement this interface. Then I have this method should be implemented inside that class and I return a random number, right? Now, how can I do with lambdas? So no arguments, right? Did you see the signature? Produce method does not take any argument. So we can put empty argument like this. And your lambda operator, I need to return a next integer. So new random object dot next integer. So you can create some object outside for random class and you can call it inside this one. So that maybe you cannot modify the status, something comes from outside. If you declare as instant field, that's fine. Whenever you call next integer, it will always generate a new random integers. Okay, if you have some other implementation you did, please let me know. Or if you do it by some other way, let me know. Okay, yeah. This is not needed. We show it as pre-Java 7 implementation. Okay, if you do, that is fine. Okay, any other question on this line? Okay, so that's about how to. So here is the answer. We don't count methods that override methods from object. So the problem 1 is not a functional interface. Problem 2, yes, it's a functional interface. So here is the solution. How to do it, I'll show you. Okay. So let's see the sample application, which we are going to talk it tomorrow about the applications, like how your Lambda expression files will work like a query language. Okay. So in pre-Java 7, here is your function. We'll take a list of string and a character C. I want to check how many inputs of the strings start with this C. So can you let me know why we put this C is integrated with empty? Because your input is a char type. So I cannot, the start with method will accept a string. So I cannot pass char. So we are going to combine with the empty string to make it as a string input. Then it will check and I'm going to add in to return a list of string. So we created a temporary list and add into an uppercase letter. So this is your regular imperative style of code, but we do it with the Lambda. See, this is what. So we will discuss tomorrow. This is a kind of application. So if I have input of list, this is your collection dot stream. Then I want to filter the name starts with the letter. So now we did a Lambda implementation. Did you notice here? Yes. So this will be functional interface. So tomorrow you should know if I want to use a filter, what kind of functional interface I can implement. So for that reason, today you need this knowledge, how I implement the functional interface. So this may be a predicate interface. Take a input and determine true or false. Map. Take a input and map to another input. And then I'm going to collect a list. So this is what a great application when you work with the Lambdas. It's like what to do, not how to do. And if I want to work this, my collection is too big collection. If I want to work it on parallelly instead of stream, you can simply call parallel stream. Okay. Yes, I told you what is the type of your Lambda expression? Any functional interface. So every Lambda expression should be a type of functional interface. So every Lambda expression need a name and type. That's what whenever we declare the Lambda expression, we put a name and the type. So that should be a suitable functional interface. So the type of expression in any functional interface is a Lambda expression can be implemented by using a functional interface. Okay, look at this scenario. Consider the Lambda expression will take two arguments and it is going to compare the two names and return a int value. So what will be the suitable functional interface for this? Can you think? We have discussed so many functional API. Maybe if you want, you can copy and paste this link and take a look at and let me know what is the suitable type I can replace for this one. Comparator, any other? Take two argument and return an int. By function, right? So I can declare this Lambda expression with two different types I identified now, right? Either a by function or maybe a comparator. Now, which one is the suitable? Depends on the scenario, right? Where I want to implement, call this expression. So for example, for this scenario, even I can put a Lambda expression type as by function, but I want to pass this one. See, this is correct. No error. When you do this one, you won't get any error. But when I pass to this function, like also comparator is also possible. And if I want to use this on collection.sort, then you can name this expression with two different names. But when I want to use it on collection.sort, which one is suitable now? I mean, compare it. Because what is your second argument type of collections? It take a compare it, right? So you can define any name. But when you apply somewhere, that function, which method type it accepts. For example, if my method need a type of string, can I pass some other type? No, the same way, collection.sort method, the second argument should be a type of comparator. So at the time, your Lambda expression, I can pass Lambda 1, right? I cannot pass Lambda 2. So this is what you need to know. This code will work because of the short method will accept only Lambda 1. When you pass Lambda 2, you will get compilation error because this method need a type of comparator. So that way you have to be careful when you pass it, but name it, no issue. According to the requirement, you can give a name. But when you call this method or pass somewhere, you have to think about. Now, this is called functions as first class citizen because this is your method function, right? I implemented this method. So I can pass this function. I need a compare method function. I can pass it as an argument. That's what all functional interface, we could call it as a first class citizen. Any question on this slide? Okay. So, we are moving to the method. Let's try some other examples. I'll give you one more exercise before moving to the method. Okay. So can you try to write a function, okay, using a lambda explosion? Okay, I'll give you some functions. You can try this exercise because without this understanding, I cannot move further. You can practice 2 more exercise now. Okay. First exercises. So for both, okay, you can try one exercise with, you can try one with own functional interface, and you can try another one with API. Okay, API functional interface. I will tell you 2 problems now. You can practice for 10 minutes. Okay, the first problem, convert an input of miles to kilometer. Okay, problem 1, convert convert the miles input to kilometer. Okay, the formula is 1.6 into miles. Okay, so kilometer is equal to 1.6 into miles. Okay, this is your formula. Okay, whatever you want, you can go. One problem, try with API. Another problem, try with own functional interface. The problem 2 is return a Boolean value. Okay, check whether the given input is odd number. Okay, return a Boolean value. Okay, please try this one. I think you can do with API. Okay, this problem do with API, and this you can try with own functional interface. Okay, own, and also why don't you try with API too for this own and API. Okay, so 10:43 now. I'll get back to you around 11:05. Okay, 11:05. Take meanwhile any break. What happened? Functional interface from the library. Okay, API means library. Okay, you can know the link which is in the slide number if you want to look at the APIs. Okay, the slide number is the link which is in slide number 49. Okay, so slide 49 has the API link. Slide 49 has the API link. Okay, so 11:05 I will get back to you.